this video, we will be discussing the demand curve. The demand curve is a relationship between price and quantity, and it's one of the most frequently used models that we're going to be addressing in this class. So the demand curve is downward sloping with price on the vertical axis, we'll call it P, and quantity on the horizontal. And this is our demand curve. And along this curve represents various quantities that are desired as prices change. Remember that in marginal analysis, we're looking for incremental changes. We want to know what happens to our quantity demanded if price decreases by $5. So we're looking at this relationship here. Now, the demand curve is always going to be downward sloping, and that's because of the law of demand. And the law of demand states that as prices increase, quantity demanded goes down, which makes sense because if you think about it, things that are higher priced, we want less of. When we have sales, when our price drops lower, we want a higher number of quantity. So it would make sense that this would be a downward sloping graph. This is also representation of an aggregate. There are various people along this graph, represented by certain individuals, represented by firms within these groups, and those combinations here of price quantity pairs are all represented on our aggregate demand curve. So one thing that I like to distinguish, and something we're going to be discussing about this curve, is we're going to be looking at increases and decreases in our demand curve and how this curve can actually shift. So before we do that, I want to bring in some examples here using market price. So let's assume that we have a market price of $5. Let's assume make the numbers simple here, that the top of this curve is $10. So the $5 is the market price. It's what needs to be paid. Now, obviously, again, this curve represents individuals. There are some individuals that are willing and able to spend more. There are some that are willing and able to spend less. And there's some that won't participate in the market at all because it's below their consumer demand is lower than the market price. So another name for this demand curve is called the willingness to pay curve. So that's why various points along this curve are going to have different additional benefits. And what I want to talk about here is something called consumer surplus. You'll be able to find all of these definitions in your vocab sheet, so we don't have to write them out. So hopefully as you're going through this course with me, you've got your vocab sheet handy. Consumer surplus is going to be the consumer's benefit from the exchange. So in this case, if the market price is $5, let's say I have an individual on this curve that is willing to pay $7. So let's say this individual exists. The market price is only $5. This individual is willing to pay $7, but since they only have to pay $5, they're going to get an additional consumer benefit of those $2 that were not spent that the consumer would be willing to spend. That $2 is referred to as consumer surplus. That's individual's consumer surplus. It is the difference between the market price and an individual's maximum willingness to pay. So that is on an individual level, call this consumer A. Consumer A's consumer surplus would be $2. Willing and able to pay $7, only has to pay $5. So gets to pay the market price and gets $2 of consumer surplus. Additionally, what we look at in terms of utility maximization and in terms of equilibrium goals for our models, we want to maximize not just individual consumer surplus, but aggregate consumer surplus. So when we're looking at this, what we're actually talking about when we say we want the total consumer surplus, we're looking for all of this. So now this entire area represents our consumer surplus. It's the difference between the market price and the maximum willingness to pay. So this is now, we're not just looking at one individual, we're looking at the aggregate of the individuals together. So this is going to be the total benefit from the exchange that's going to be received by our consumers. Now, this portion down here of the demand curve, they won't participate at all. They do not value whatever this market we're looking at. Let's say we're looking at the market for apples. They won't value that highly enough, so they won't participate in that market enough. So to answer then this question of what is the total consumer surplus in this area at a market price of $5, well, what we need to know is the area of this triangle. Let's toss a figure in here. Let's say at $5, the quantity demanded is 10. What we have now is enough information to calculate the area of this triangle. So area of a triangle is equal to 1/2 base times height. So base times height divided by 2. So in this situation, our base is 10 times our height is 5 divided by 2. 10 times 5 is 50. 50 divided by 2 is 25. So in our example here, our total amount for consumer surplus at a market price of $5, where we have a quantity demanded as 10, that we will have $25 of total consumer surplus. So this is the demand curve. And what we're going to look at doing is actually seeing how this demand curve shifts and how it changes. Now, there's a difference here that I'd like to point out. There's a difference between a change in demand and a change in quantity demanded. So I'm going to erase some of this information, kind of clear our board here. So what happens here? Anytime we just change price or just change quantity, we have a change in quantity demanded. But when we don't hear that word quantity in there, we can actually end up shifting this entire curve. Now, let's introduce some definitions here. Something that's important to understand is a distinction between endogenous and exogenous variables. So endogenous variables are variables that are inside of the model. So in this example, our endogenous variables are P and Q, price and quantity. Our exogenous variables are anything outside of our model that might change things within our model. And that's what we're going to be looking at. We're going to be looking at the variables and the situations that occur that actually make this curve not just move from one point to another, but actually make it shift from one direction or the other. So first, let's kind of walk through and see what this looks like. So let's look at an increase in demand. So we say demand increase. I like to use arrows for increase and decrease, so you'll often see me abbreviate. Increase in demand. Now see, we're missing that word quantity here, so we know we're not just changing to another point on our curve. We're increasing demand, which means we're increasing the entire curve. So an increase in demand is a shift of our curve to the right, going from demand 1, demand 2. So now what this actually means, let's introduce and see how our quantity and price points change as we look at this curve. Originally, let's put some numbers in this again. Let's call this 5, 10, and let's call this 20. So as we see here, at the original quantity and at the original price, what we have is when our demand curve increases, we are willing to spend more. We are willing to increase our consumption, so we're willing to spend higher prices than we were before for the same quantities. Or if we hold that price constant, we want greater quantities. So when our demand increases, we shift our demand curve to the right. So at the same price, we want more. At the same quantity, we are willing to pay a higher price. So this is an increase in demand. A decrease is just the opposite of this situation. So if we have a decrease in demand, so let's say we move from D2 back down to D1, that means that at all price points, we are willing to spend less. So if our demand decreases, at the same price, we are willing to demand less. At the same quantity, we are willing to pay less. So this is our simple shifting mechanism. And in our next video, we're going to go over the exogenous variables that actually make these shifts happen and actually cause our demand curve to shift.